Ciao! Today's video is a quick update about our demo in labeling cloud events. This demo uses several technologies. We are using, of course, Drools and Yard for the role definition. Then we are using Cogito, of course, for cloud native based decisioning. We are using Quarkus, of course, and then cloud events because these are the data that we want to process. We are using Kafka, and we are using PostgreSQL as our data store. Because we're using specifically PostgreSQL for very interesting type capabilities that this data store has, then we can use Hibernate types to define our custom types on top of it. And finally, we're using Quarkus Quinoa together with Patternfly for the UI. This is a diagram, a very high-level diagram of the architecture for this demo. So on the left-hand side, we have our incoming message. This is the cloud event that we want to process by labeling it. We have an endpoint which represents our ingress, and we place immediately the message on a Kafka topic. So this represents a queue in order to isolate the incoming part with the rest of the processing pipeline. Processing pipeline that starts with a labeling processor. This is the part that takes the rules defined on top of Drools and Yard in order to enrich the cloud event with the labels that we wanted. And now we have, as a result, our message now enriched with the label, and we are storing it into our data store, as I mentioned, PostgreSQL, specifically because we're using some very interesting technologies that is enabled here. Finally, thanks to that, we can use some advanced query capabilities of the PostgreSQL. So we have the capability to query and to potentially reprocess the same type of context, the same type of message, if so we needed, after some manual augmentation. So this is the capability for today's demo. We are going to see some GUI that will enable us at least to use these very rich capabilities from the query side. So we're going to see how we can use this specific type of SQL extension of PostgreSQL in order to query the message accordingly. And with that, we can move now to the demo. Alright, so this is our cloud event, an example cloud event. As you can see, there are the parts that are related to the metadata of the cloud event specification, and then we have our payload. Our payload presents some host load, some server load, some server metrics. We are using here, for instance, we have information about the host names and some metrics. So what we want to do is that we want to classify in this demo at least the host name based on its relevance to the department, to the unit, to the person who is responsible, or to the team that is responsible for that. So here we can do that based on some simple decision table. So the first thing that we may want to do is that we want to have some labeling based on the geographical location. So for that, we can use a very simple decision table, and depending on the host name or some content on the host name, more precisely, we are going to set a label. As you can see, the label is hierarchical. It is hierarchical thanks to the dot separator. So for instance, here is like EMEA, Italy, Milan, or you may have Rome, UK, London, or Canada, Toronto. So this is one simple decision table. Another one that we may want, we are interested to do could be about having some type definition. So depending on the host name or some content on the host name, we may want to decide which type of server that is, if it is related to a DB or to an S. And of course, this is the part where the maybe different unit, different department have different naming convention. And this is the part where you can encode that. As you can see, for instance, here, there are some Italian naming convention or some more UK English type of convention. And finally, based on the location and the type, we may want to decide where to dispatch this information. So for instance, we may want to determine who is on call, and we can have some hierarchical as well here to save some EMEA database admin or some more high-level corporate database admin or some general IT department that we have available. So in this case, we are going to act on location and type, which are the result of the previous rule definition. So this is how the logic works, and we can see that in action. So we can take this cloud event, and now I can move to my OpenAPI. So actually here, what I have already is the system ongoing. I've tested it with some test data, test 1, 2, and 3. So let's do a new one. As we learn from the architecture, we have an ingress. So we are going to use that one. And we are going to send that cloud event. Here, let's give it meaningful here. No, let's do it here. I can say mm1 just to later reference it. And we can execute it. And this is now been sent. Okay, 200. So if I go back here and I refresh the page, I can see that this information is available and is already been labeled. As you can see here, I have some of the labels that have been applied. So let's see it in more detail. In this case here, I have the number. This is a sequential number in our demo. This is the UUID that I manually set in order just to make sure. And then as you can see, the rules have been applied on the context here of the cloud event data. And based on that, we have defined that indeed base di dati would have represented a database. The location, because it's milano.local, then we can identify the office. And then finally, we can identify there is a, in this case for this demo, for these rules, there is a specific on-call database admin in EMEA that can answer to that. So this is a complete flow. Let's dive now in a bit more detail about how this works in the backend side. All right, let's connect to the database because there is something that I want to show in there. So that is this one, docker exec city shell, and then PostgreSQL menu hibernate default, right? So what we have in here, so this is our table for the case, and then we can see it in a bit more detail. So this is our database table in PostgreSQL that store the information that we sent and that we processed or we can reprocess. So as we can see, we have classic just id increment. This is the UUID that is coming from the metadata. So it's currently stored in a specific column in this case. The context is stored as JSONB. So this is the binary store that PostgreSQL allow us to use in order to store the JSON and to potentially to query on that directly. And then the labels are stored with an L3 array. So because each single label is hierarchical, we can use the L3. And this allows us to actually query based on some specific part of the hierarchy. Because we have potentially many type of labels, then it is an array. And then we have some indexing. This is simply applied from the PostgreSQL manual in order to make this very effective, but I have to admit I'm not a PostgreSQL expert, so actually if somebody looking this video has some suggestion to improve the indexing on this table, I'll be really happy to know, so you can leave a comment to the video down below. So thank you in advance in case for that. So this is the basic. Now that we've seen this how the data is stored, then I can present how we can actually make some specific query. Alright, so to demonstrate some of the query capabilities, let's issue this query. So in this case, we try to select for cases which were tagged with at least one label having on-call corp. And we know that actually we don't have any, because there was one that was for the EMEA. And of course this is presented. Then of course this is a very specific complete match that you can see actually here for the root part, this root and branch part of this L3. And as you can see, this is for DB admin. So if you wanted to nail down specifically for that team, so you can do that in this case. Of course, it will return the same result. And of course, you can query for just the root without any branches. So this is for the on-call. So just as a reminder, this is the full content of our table. So as you can see that minus then and at sign allow us to query for a specific root, branch, and potentially leaf of one specific tag. So these are the capabilities that are allowed thanks to the fact that we're using that L3. To make the query more simple, of course, we have some search here, and here you can use the same capabilities. So actually, to make these things a bit more interesting, let's fire another maybe event. So let's call it MM2, and then let's say that this is like, I don't know, shared London. So this is some potentially some shared drive in London, just to make sure. Let's do it this way. So 200, okay. Now if I refresh here, whoops. Sorry, I'm not the best with making UI. So this is a failure. That is likely some failure on the React app. I'm sorry, I'm really not the most qualified on making a React app. But as you can see here, we can use the same concept in order to query for that. So similarly, we can use something that is allowed with is enriched with a label that has at least a type for the root of the label itself, and then we can even query for databases and similarly. Luckily as well, there is a very powerful match, so we can query for a specific branch regardless of where it is found in the tag. So if I do something like this, then everything which is related to EMEA is appearing, as you can see here. So the point here I'm trying to make is that if you notice, this resembles regular expression, but it is not. This is really another powerful operator of our of the PostgreSQL type, and allow us to do a specific match. So for instance, here we can use we can search for database, and it finds, yes, there is an element, either a branch or a leaf or a root, that is part of a label of the system. And of course, you can use that in order to indeed see your details and potentially re-augment by applying some new label and see if there is some automatic processing to be done. This is the way it works. So I hope this was an interesting demo to see in more detail. And there you have it. Here is our demo that allow us to actually label CloudEvent based on some decision logic that we expressed with the decision table expressed with the yard and rules. I hope this demo was interesting, and with that, I will see you at the next one. Before you go, do you know that 80% of you watching this video are likely not subscribed? So if you find this video helpful, I would really appreciate if you consider clicking that subscribe button. It really helps a lot. Leave us a thumbs up or a comment for a potential feedback for a new video. It really helps drive the channel forward, and it really means a lot to me. So thank you for your consideration. Ciao!